Hey everyone, and welcome to the course. My name is Daniel Buckley, and I'll be your instructor. In this course, we are going to have an introductory look at the Unreal Engine. Now, what is the Unreal Engine? Well, Unreal is a powerful game engine used all across the industry, all the way from single solo developers to large AAA companies. Unreal has been used to make some of the most popular games out there. And in this course, we are going to be looking at how we can install the engine, set it up, and then learn how it works so we can create the games that we want to make. So, in this course, we are going to cover a wide range of topics. We're going to be looking at an overview of the editor, so we know what all the buttons and windows and different panels do. We'll be looking at working with actors. These are essentially the objects or entities that make up everything in our game. We'll then be looking at lighting. We'll be looking at physics. We'll then be looking at blueprints, which allow us to create, blueprints for certain things. And then we'll be looking at visual scripting with blueprints, and this is where we are going to get into not necessarily coding, but a more visual form of coding, where we have nodes that we can drag and drop and connect with lines to add behaviors and logic to our game. For example, what you see on screen right here is how we can set up some basic player movement. We don't need to type out code. All we need to do is connect these nodes together and the engine will get our player moving around. So we're going to go over in quite a bit of detail from the very basics of how to set up blueprint visual scripting. We'll be going over all the different fundamentals. So hopefully you can begin creating games at the end of this course. Zenva is an online learning academy with over 1 million students. We feature a wide range of courses for people who are just starting out or for those who just want to learn something new. The courses are also very versatile, allowing you to learn in really whatever way you want. You can choose to view the online video tutorials, read the included lesson summaries, or follow along with the instructor with included course files. Now let's get started with the first lesson. Hey everyone, in this lesson we are going to look at how we can install Unreal Engine. Now, first things first, let's go over to the unrealengine.com website, and here is where we can begin that process. So what we're going to do is go down to where we have the blue Get Unreal Engine button right here and click on that. And this is going to take us to the download page. Now, Unreal Engine is a product of Epic Games, so it is installed via the Epic Games launcher. Now, if you already have installed the Epic Games launcher, then you can just skip this step, but if not, you need to follow this process. We are going to go and click on the blue download launcher button, which is going to download the launcher installer. We want to go through that process. And while that's happening, also go ahead and create an Epic Games account. You can do that by going to the top right corner of the screen and select sign in. And here is where we can then choose to create an account, or you can log in via Google or any of these other ways. Okay, so make sure that you have Epic Games launcher installed, you have an account, and once that is done, you should then have the launcher like this. Now, on the left-hand side, we essentially have all the different windows we can navigate to. By default, you'll probably be on the store, but I want you to go down to Unreal Engine right here, okay? Now, on the Unreal Engine page, at the top you'll see there are a number of different tabs: news, samples, library, etc. We are going to go over to library. Now, inside library is where we can manage our engine versions as well as all of the different projects or games that we have created. So the first step, what we're going to do is go to where we have engine versions and click on the plus icon right here. That is then going to add a new version of the engine here. And we want to click on the yellow install button. Now, I already have a recent version of Unreal installed, so I'm not going to go through that process, but you should then have it begin the installation process. Now, do note that Unreal is quite large in file size. It can be up to and around 20 gigabytes. So do make sure you have enough space on your computer for that. And do take the time to let it install, as it can take quite some time depending on your internet speed and other factors. But once that is done, you should then see that the install version here has a launch button, and that means your engine is fully installed and ready to go. Now, in the next lesson, we are going to be looking at creating our first Unreal Engine project. So thanks for watching, and I'll see you all then in the next lesson. In this lesson, we are going to be looking at how we can create a brand new Unreal Engine project and start creating some games. So what we're going to do is on the Epic Games launcher, over inside of the Unreal section and in the library tab, make sure that you have a version of the engine installed. And to know it's installed, you'll see that the launch button is visible and clickable. So I'm going to click on launch right here on my engine version, and that is going to open up the launcher. And that is going to open up the Unreal Project browser. Now, the project browser is essentially where we can choose to either open an existing project or create a new project. Now, on the left-hand side, you'll see a bunch of different things such as games, film/video. These are essentially template categories. Because Unreal is a very versatile engine, not only can people create games with it, but they also create simulations, architecture, walkthroughs. They can even use it for VFX in movies. But for our case, we want to create games. So I'm going to make sure I am on the games category right here. And then you'll see a number of different templates. Okay, Unreal comes packed with a bunch of cool templates that can help you learn. But since we are learning the engine from scratch, we want to have a nice blank project to build upon. So I'm going to select the blank template right here. And then on the right hand side, you'll see there are a bunch of different settings we can modify. I'm not actually going to go ahead and change any of these. But what I will change is if we go down to the bottom, we have two things. We have the project location, which is where on our computer we want to save the project files to. I recommend creating a brand new folder for all of your Unreal projects. I've gone ahead and created a folder called Unreal Projects, and that is where I basically store all of my game files. Then on the right-hand side, we can give it a project name. Okay, here I'm simply going to call this Intro to Unreal. Then we can click on the blue create button, and that is going to open up the engine. Okay, and here we are inside of the Unreal Engine editor. This is where we are going to be creating our games. Now, at first glance, there is a lot of buttons, a lot of text, a lot of selections on screen, and it may look a bit confusing. So in the next lesson, we are going to have an overview of how all these little things and these windows work so that when we get to creating our games, we have an understanding of what we need to do and how we can do it. So thanks for watching, and I'll see you all then. Hey everyone, in this lesson, we are going to have a look at the Unreal Engine editor and just have an overview of what we are looking at right here. So inside of Unreal, you'll notice that everything is a bit complex. There's a lot of buttons, a lot of little bits of text. So what do? Well, it's important to know that Unreal is divided up into a number of different windows, and each window serves a specific purpose in creating our games. So on screen right now, we can see three windows. On the left-hand side, which is taking up the majority of the screen space, is our viewport. This is essentially a window into our level, and this is where we can edit all the different objects, we can build out our levels, we can draw on our terrain, we can paint in trees, move objects around. Everything to do with level design and constructing our levels is done through this window. Then on the right-hand side, we have two other windows. We have the outliner and we have the details window. Now, inside of Unreal, everything in your game is constructed using actors. An actor is essentially an object or an entity which serves a specific purpose. For example, your player will be an actor. The light that is shining down as the sun is an actor. The terrain that we can see before us here, this is an actor. Now, in the outliner, you can see we have a bunch of different things listed here, and these are all actors. And you can see we have something like directional light. This actor here is in charge of being the sun, essentially lighting our environment. We have player start, which defines where in the world the player is going to spawn. Each of these actors serve a specific purpose in our game. Now, if I click on one of these actors, for example, the directional light, it is going to select it in the outliner. It's also going to select it in the viewport here, but directional light isn't really something we move around. And then down here in the details panel, you can see that it fills with all this information. And the details panel is in charge of basically showing us an in-depth look at what actor we currently have selected, in our case, the directional light. And you'll notice that we have this long list of different properties here, and these are all things we can change. These are essentially the properties that make up the directional light. So if I scroll down here to light, for example, you can see I can change the intensity, I can change the light color, and if I click on this white box, that's going to open up a color picker where I can change the light of our sun. Okay, I'm just going to go Control Z to undo that. We can change the intensity by clicking and dragging, and that's going to change how bright our level is. I'm going to undo that as well. And yeah, there are many other properties here. Feel free to go ahead and select on different actors and modify their properties just to see what they do. You can also hover over a property to get a little bit of information about what it does. For example, the intensity changes the maximum illumination from the light. And yeah, there are a lot of properties here for you to explore. Now, those are the main 3 windows that we're going to be using inside of Unreal. There are also many others, probably hundreds, but those are all for specific use cases, such as if you want to work with animation or audio, those things. But there is one more window that is very important that we do need to look at, and that is the content drawer. Now, where is the content drawer? We can't see it anywhere here. Well, there's 2 ways we can see the content drawer. First of all, we can go down to the bottom left corner of our screen and click on content drawer right here to open it up. Or alternatively, we can go Control Space and that will open up the content drawer as well. Now, the content drawer is essentially a file explorer. You can see on the left-hand side, we have folders here, and in the center is where we essentially see the contents of whatever folder we are currently in. On the left-hand side, if I click on All, for example, that's going to show us the contents of the All folder. If I go to Content, it's going to show we have nothing here. If I go to Engine, this is going to show all of the folders and files related to the Unreal Engine. Now, this content drawer is where we are going to store all of the different assets for our game. And an asset is essentially going to be things such as textures, 3D models, sound effects, anything that you want in your game is going to be stored in the content drawer. And likewise, this is essentially just showing us the files and folders that are already on our computer. So, we're going to be working on adding new content to the folder in future lessons, but for now, just note you can go Control Space to open up the content drawer or click on it down here at the bottom left. Okay, so that is a quick overview of the main 4 windows that we'll be using inside of Unreal. Now, if you don't like the current layout, for example, you might want the outliner to be a bit wider, we can actually click and hover over between the window borders and click and drag to essentially resize them. You can see here, I can resize these windows like so. So for example, if I want to see the details a bit more, I can drag it up like so. Alternatively, we can also click and drag on the tabs here. So you see each window has a little tab at the top. Click and drag on that to move it around and position it wherever we wish. So we could put it over on the left-hand side, or we could dock it alongside the outliner by dragging it up. And now, like a web browser, we have multiple tabs we can jump between. We can essentially do whatever we want with these windows, so we can position them however we like in whatever way. But if you want to reset back to the original layout, simply go up to Window, then down to Load Layout, and then to Default Editor Layout. And that will reset the editor in the default layout. Now, in the next lesson, we are going to explore how we can navigate the level viewport window right here, because at the moment, it's a bit hard to really modify anything. If there's a tree in the distance, it'll be hard to click on it. So how do we fly around this window? How do we select objects? How do we focus in on them? That is what we're going to be looking at in the next lesson. So thanks for watching, and I'll see you all then. Hey everyone, in this lesson, we are going to be looking at how we can navigate the level viewport right here. Because our level viewport is very important, as this is where we are going to be constructing our worlds. This is where we're going to be adding in all of the different elements and interactables for the player to use. This is where we are going to be designing our levels, the ups, the downs, the trees, the rocks, building everything to construct our game. And we can't really do that from this static perspective right here. So we need a way of navigating the viewport. So to begin, if we hold down the right mouse button and look around with the mouse, you'll see we can essentially look around as if it's a first-person game. Now, while doing this, we can use the W, A, S, and D keys to move around. Now, you may notice that you move pretty slowly, and if you look in the corner, you can see we are in fact moving, but it's very slow, and that is because we are in this very large world right here. So what we can do is, while holding down the right mouse, scroll up on your scroll wheel, and you should see at the top of the screen a little number increasing. So now we are at a speed of 2, and our camera is now flying around a lot quicker. While holding down right mouse, we can also press E to go up and Q to go down. So we have W, A, S, D, E, and Q. Okay, so we got this. Now, if I let go of the right mouse button, we can use the scroll wheel to zoom in. And you can see here, I'm scrolling in, I can zoom out. I can also hold down the middle mouse and move my mouse around to pan the screen. Okay, so those are the main ways of navigating around the viewport. Now, when I say viewport, I don't just mean this 3D perspective. We can also have the traditional CAD layout where you have the top view, front view, perspective view. So to do that, what we can do is go up to where we have perspective here, and you'll see we can change our view. Right now it's set to perspective, which is this 3D view, but if I go top, that is going to change to a wireframe top-down view. I can also then change this to bottom or left or right, and if you want to design levels or pinpoint exactly where certain things are going, this might be the way to do it. Okay, so I'm just going to go back into our perspective view right here. And that's how we can navigate the level viewport right here. Now, in the next lesson, we are going to be going over what a level is and how we can create a new level. So thanks for watching, and I'll see you all then. Welcome back, everyone. In this lesson, we are going to be looking at levels and how to create a level. Now, in Unreal, a level is essentially a collection of actors, and a level you can think of, well, basically as a level in a game. Each level is its own self-contained area. We might have the player get from one location to another. Different levels might have different theming or different things going on, and that is essentially what levels are in Unreal. So, if we look in the outliner on the right-hand side, we can see all of the actors in the current level, okay? So essentially, a level with no actors is basically just a black void, but when we start adding in actors, adding in an atmosphere, some terrain, a player, some objects, some enemies, that will then flesh out and build our level into whatever we want it to be. At the moment, though, this level is quite blank in terms of there's nothing real gameplay related. So let's go ahead and create a new level. To create a new level, we want to go up to File and then go New Level. Now, here we can choose from one of 4 templates. The template we have open right now is this open world, but we want to go over to Basic. Okay, I'm then going to click Create, and this is going to create a brand new level. You can see here in the outliner, we have a sort of different array of actors here, a bit less than the previous one, but these are all new actors. And if we look around our level here, you can see, let me just slow down the camera a little bit with the scroll wheel. You can see this is what the level looks like. We have this, essentially this cube or this rectangle on the ground. We have a skybox, we have a sun, and it's pretty blank. But throughout the course, we're going to add things to it in order to learn how to use the Unreal Engine. Now, whenever you have a level, you of course need to save it because this needs to be saved to our computer. So what I'm going to do is go to the top left corner here and click on the Save Current Level to Disk button, or Control S. And this is going to ask us to choose where we want to save it. Now, this right here is essentially our content drawer. So if we go over to the content folder, I'm going to go ahead and right click. I'm going to create a new folder here inside of content called Levels. And then inside the Levels folder, let's double click on that. I am going to rename my level down here, and I'm going to call this one, let's just say, we'll call this Test Level, and then click Save. So there we go. You can see now at the top it says Test Level, the name of our level, and we can then begin adding stuff and building out our game. But if we go Control Space to open up our content drawer, you can see we now have a Levels folder, and inside of here we have our Test Level. Now, if you have multiple levels in your game, you'll of course want to jump between them in order to work on them. Now, to open a level, you simply just need to double click on it here inside of the content drawer. and that is then going to open up the level. So if I had a level 2, for example, and I double clicked on that, it would then open it up and we will then edit that. Okay. Now, in the next lesson, we are going to be looking at how we can create new actors. So thanks for watching, and I'll see you all then. Hey everyone, in this lesson, we are going to be looking at how we can add new actors to our Unreal level. So by default, we have all of these actors already in our map or in our level. And these are mostly related to lighting, okay? You can see you have directional light, fog, atmosphere, skylight, etc. But we eventually want to add in a player, we want to add in obstacles, items, enemies, stuff like that. So how can we add these in? Well, if we want to add in basic things such as cubes and spheres for the player to jump around on, what we need to do is go to the top of our screen here and look at this button which has a little cube with a plus icon. And this says quickly add to the project. If we click on this, you'll see we can then go down to where it says place actors, and we have all these different categories of actors we can place. Now, there are more actors, of course, that exist in Unreal, and we can also create our own custom actors, but these are a lot of the main presets we'll be using. So if I go down to shapes, you can see we have cube, sphere, cylinder, cone, plane, all these different shapes we might want to quickly add in to modify. So if I click on sphere, for example, that is going to create a brand new sphere inside of my level. And in the outliner, it is going to be added. And then down in the details panel, we can see all of the sphere's properties. So we have like location, rotation, scale. We can change the material, so the visual look of the sphere. Now, another way to add actors is with its own dedicated window. So if I go up to window and then go down to where we have the place actors window, I'm going to select that. It's going to add it to our editor here. I might want to move it around, so I'm actually going to bring this and dock it next to the outliner so I can switch between outliner and place actors. This is just where I like to put it. Let's make this window a bit bigger. I'm going to go down to where we have shapes, and just like before, we have all of these shapes here, and we can just click and drag them into our level here, and you can see I can kind of just drag it in, and it places it in our level. I can do the same thing with a cylinder, a plane, a cone, etc. And there are also other types of actors. We can add in a point light here. And yeah, you can see we can now just quickly drag and drop things into our level to begin building it out. But how do we move these things around? How do we change their size, their orientation? Well, in the next lesson, we are going to be looking at how to do just that. But for now, let's go ahead and just undo all these changes. So we can go Control Z to undo these, adding them in, or what we can do alternatively is if we go to the outliner, select an actor from the list and hit the delete key on our keyboard. Or what we can do is just select the actor inside of the level viewport here. You can see if I click in the level viewport, it is going to select whatever I am hovering over. So we can select the floor, we can select the sphere, and you'll see there is this orange outline around whatever we have currently selected. And then we can likewise hit the delete key to remove it. So in the next lesson, we're going to look at how we can begin moving, rotating, and scaling our actors. So thanks for watching, and I'll see you all then. Hey everyone, in this lesson, we are going to be looking at using the translate, rotate, and scale tools. These three tools will allow us to actually move our objects around in 3D space, rotate them, and change their size. So first of all, we need an actual object or an actor that we want to be able to move and position around. So I'm going to go to my Place Actors tab that I created in the previous lesson. If you don't have this, simply go up to Window, then click on Place Actors, and this will create that Place Actors window, which you can dock wherever you wish. I'm then going to go down to the Shapes tab, and I am going to select, let's just say, the cube, and I'm going to drag that cube into our level here. Now, what I can do is with the cube selected, I can press F on my keyboard, and that is going to focus the camera here, the level viewport, into the cube. Now, I can go back to the outliner, and alternatively, I can click on an actor here and press F to focus in on that. So I click on the cube again, and it will focus in. So if ever you lose an actor in your level somewhere, simply select it in the outliner and press F. Now, this cube right here and pretty much every other actor that can be positioned in 3D space will have these transform properties in the details window. And you'll notice that each of these have a red, a green, and a blue value, okay? Now, these three values, for example, location, this determines where in 3D space this object is positioned. We need to give it three values to pinpoint a position in 3D space, okay? Think of a 2D graph where you have an X and a Y axis. You need an X and a Y position in order to pinpoint a specific location. Thus, in 3 dimensions, we need 3. Red represents the X axis, green represents Y, and blue represents the Z axis. We have the exact same thing then for rotation and scale. Now, how do we move an object around? Well, we could simply just hover over one of these location axes and click and drag to begin moving it around like so. Okay, and you notice that the red one moves it side to side, green moves it, or which is the Y-axis, moves it the other direction, and blue, which is Z, moves it up and down. Now, we can also go ahead and manually set values by clicking, and then we might want to make this 0 on the X, 0 on the Y, and 0 on the Z, and that is going to position it right in the center of our level here. Now, what are these numbers and what do they mean? If I set X here to be 100, that is going to move the cube this amount of distance. This essentially is centimeters, okay? So 100 on the X means it is 1 meter along the X. We also then have rotation. You'll notice if I begin rotating along the X-axis, it rotates it like so. Do the same thing for the Y and for the Z. Now, for rotation, this is in terms of degrees. So if I set the Y here to be 45, there is going to be a 45-degree rotation applied to the cube. And then finally, we have scale. Now, I'm just going to move the cube up a little bit. So I'm just going to adjust its Y or its Z location here. If I then begin modifying the scale properties, you can see I can change its size along the X, the Y, and the Z axes. Alternatively, I could click on this little lock icon, which essentially means if I move one axis, it's going to increase it uniformly along all others. Okay, now scale is not in terms of degrees or centimeters, but rather you can think of it as a multiplier. Its default size is going to be 1, meaning it is 1 times its original size. If I set, for example, the X to be 2, now you can see it is twice as long. If I set this to be 0.5, it is going to be half as long. So that is how scale works. Now, what we can then do is not just modify the location, rotation, and scale via the details panel here, as it can be quite cumbersome if we're trying to position something in the world here. So what we can do is use our tools. Now, if we look at the top of our screen here, we have 4 tools. We have select objects, select and translate, select and rotate, and select and scale. Now, we should already by default have select objects, that tool enabled, which you can see it is colored blue, or we can press Q on our keyboard. And this allows us to click and select objects inside our level viewport here. Now, if we go over to the translate tool, which we can click on or press W as a keyboard shortcut, this little thing will appear on screen, these 3 arrows. And you may notice that each of these colors are representative of their corresponding axis. If we click and drag on red, that is going to modify the X-axis, as you can see in the details panel here. Blue is going to modify the Z-axis, and green is going to modify the Y-axis, and you can see those things changing right there. Alternatively, we could click and drag on the little squares in between 2 of those axes to sort of pan along specific pairs of axes. For example, if you want to move something along the surface of the ground, you can click and drag on this one here. As you can see, it highlights both the red and the green, and we can move it like so. Also, if you click and drag on the white in the center, that is going to move the cube relative to the camera's orientation. Okay, so there are many ways of moving the cube around, as you can see here. Now, we have 2 other tools. We also, next to the Move tool, have the Rotate tool. And if we select that with the keyboard shortcut E, it's going to appear with a very similar overlay. We have the red, green, and blue selections here, but these will not move the object, rather it will rotate it. So if I click and drag on the blue here, that's going to rotate it around. And we can even see exactly what degrees it has been set to and how far it has been rotated on screen here, which is very nice. Same thing for the green, which represents the Y rotation, and red for the X rotation. Now, you may notice that it is snapping. Same thing with our movement. By default, our movement is snappy. So if you want to have more free-form movement, we can go to the top here and select on this grid, which is going to basically toggle snapping. So you can see it's smooth here, or I can turn on snapping like so. And I can also then set the value that we want to snap it to. Same thing for rotation. If I go to my rotate tool, you'll see here that I can enable or disable snapping. So here's it with it disabled, and then here is with it enabled again at 10-degree increments. I'm just going to go ahead and set the rotation to 0, 0, 0 here in the details panel, because we are now going to move on to our final tool, which is the scale tool. So if we select the scale tool here, keyboard shortcut R, it looks very similar to the move tool, but instead of arrows, we have cubes at the end. And like with the translate tool, we can click and drag on these to scale along the specified axes. Or if we go ahead and click and drag on the central white cube, that is going to scale it uniformly along all axes like so. And like with the move and the rotate, we can also enable and disable snapping. So this can give us now smooth or very precise scaling. Or we can enable snapping and change the increment here to whatever we see fit. So there we go. That is a look at the location, rotation, and scale properties, as well as their associated tools. Okay, between now and the next lesson, I want you to go ahead and complete this challenge. Using the translate, rotate, and scale tools, I want you to create the stick figure you can see here. Okay, you'll need to create a number of different cubes as well as a sphere actor, and I want you to position, rotate, and scale them so they match what you see on screen right now. So have a go at that, and I'll see you all in the next lesson when we'll go over the solution. Okay, so I hope you had to go at that challenge. Let's now hop into Unreal and have a look at how we can set this up. So inside of Unreal, what we're going to do is go to our Place Actors window, and we want to go down to Shapes, and I'm going to start off with the torso. So I'm going to drag in a cube here. I'm then going to go to my Move tool, which I can go to by pressing W on the keyboard. Move it up here into the sky. I'm then going to go to the Scale tool by pressing R, and I'm just going to scale it down a little bit here. I'm also going to go ahead and disable snapping on scaling so that we can get nice smooth scales, and then scale it up like so. And there we go. That is our body. Next, for our legs, actually I'm just going to move it up a little bit. I am going to duplicate this with Control D, and if I go to the outliner and press Control D, that's going to duplicate the cube here. Or alternatively, I could right click on the cube, go down to Edit, and then Duplicate, and that is going to create a copy. Now what I'm going to do is move this down here. I'm going to go to my Rotate tool and rotate it like so, using E to go to the Rotate tool, scale it down a little bit, and then position this leg like so. Duplicate that again with Control D, rotate it around the other way, and then move it over here. And also when you duplicate, you may notice that it does offset it a little bit, so we can just then position it back in its original location there. Next for the arms, and I think my legs are a bit off, so I'm just going to rotate this like so. There we go. And there we go. Okay. Next for the arms, I'm going to duplicate the torso. I'm then going to rotate it 90 degrees. And then we want the arms to be a bit thinner than the torso. So what I'm going to do is simply go to my scale tool with R, scale it down, and then scale it outwards here. And there we go. We've got the arms. And then finally for the head, what we can do is go to the Place Actors window and drag in the sphere on top of the head here. All we need to do now is just scale this up a little bit and position it so it is in the correct location. And there we go. We now have our stick figure set up. We can also go ahead and rename these objects so we know what they are, because if we go to the outliner and have a look, you'll see we have cube, cube 2, cube 3, and they just don't really mean much to us. So what we need to do is set it up so that we know exactly what each of these actors are. And to do that, let's select the head, for example. We can right click on the sphere and then go down to Edit and then Rename, or the keyboard shortcut F2. And I'm going to call this one Head. I'm then going to select the torso here, press F2 and call this one Torso. I'm going to select the arms, F2, call this Arms. I'm going to select the leg, F2, this is going to be the right leg, And then we can do the same thing for the left leg, like so. Now, when we look in the outliner, we can see exactly where the arms, the head, the left leg, the right leg, the torso are. Just like every other actor here, they have a name that matches what they are. So at a quick glance, we can easily select the specific thing that we need. Hey everyone, in this lesson, we are going to be having a look at materials inside of Unreal. So what is a material? Well, essentially, a material is something that defines how an object is rendered on screen. Okay, for example, this ground right here has a material which is not really reflective at all, and it has this grid texture. Okay, so that is what is being defined for this ground material. Likewise, our skybox here also has materials applied to give it the blue sky, as well as the clouds. Now, we're going to go very simple with this. We're going to start by creating just a simple sphere. So if we go over to place actors, we can drag in a sphere. Let's just move it over here. And what you'll notice on our sphere is that it is white. Okay, it's not particularly reflective. It doesn't really look like it's made of metal, but it does have a material. This is just a basic white material. Now, for your games, you probably want something that's a bit more exciting than just this white material. So we're going to go over how we can create a material. But first of all, how do we actually change the sphere's material? Well, if we select it and then go to the details panel, you can see here if we scroll down to the bottom, we have our materials drop down. And here you'll see that the sphere has a basic shape material. We can see a little preview image here, and we can also, if we click on the drop down, change its material. Now, by default, Unreal has a bunch of materials, but these are not really materials you want to use in your game. For example, frame material looks a bit like this, which may be alright for a force field, but generally, these materials are for in-engine stuff. So what we need to do is create our own material. Now, to create material, I'm going to open up the content drawer by going Control Space. And here inside of our content folder, I'm going to create a brand new folder right here, and I'm going to call it materials. Now, inside this materials folder, I'm then going to right click, and whenever I right click, it is going to display a bunch of different things, and all these things are assets we can create. You can see we can create audio assets, we can create animation, input, materials, physics, textures, all these sorts of things. A lot of the common ones that you will be creating are actually going to be up here, and you can see one of them is material. So I'm going to click on material right here, and we can give it a name. I'm just going to call this one test sphere and hit enter. Now you'll see we have this material created. So how can we apply this material? Well, like I mentioned before, we could go down to the details panel with the sphere selected and open up this little drop down, search for our test sphere, and there it is. So we can then click on it and that will apply it like so. Or what we can do is open the content drawer and simply drag and drop the material onto the sphere, and it is then applied. So there we go, that is the basic material applied to the sphere, but again, we probably want to change how it looks, because right now, it's very basic. So what we're going to do is, inside of our content drawer, we are going to double click on the material. And what this is going to do is open up a new editor. Okay, Unreal, as I mentioned before, is divided up into a number of different windows. We have our level viewport, we have our outliner, we have our details window, and these together form the level editor. This is where we build and construct and edit our levels. But what if we want to construct and edit materials? Well, we don't do that in the level editor, we do that in the material editor, which is this new window which appeared. Now, it may be a bit cumbersome to try and manage these different windows, so what we can do is, just like a web browser, click and drag at the test sphere tab at the top and dock that next to our test level. Now we can jump between these tabs as if we are on a web browser, okay? So here we have our level editor where we construct our levels, and here we have our material editor where we construct our materials. Now, inside the material editor, it may look a bit confusing. We have all these settings on the left-hand side. We have this big window here called a material graph. What's going on here? Well, materials can be quite a complex topic, and in the games industry, there are people's jobs that are entirely dedicated to making materials. So it can be quite an overwhelming topic, but we're going to be very basic with what we do here today, okay? Basically, a material, you can define many different properties, such as the color, how metal-like it is, how reflective it is, as well as other things which we're going to go over. So, first of all, in the material editor, on the top left corner, we have our preview. This is basically showing us what our material looks like. Down in the bottom left, we have our material properties. These are the overall things such as, is this material translucent? Is it double-sided? Is it going to cast shadows? That sort of thing. And on the right-hand side, this window here is the graph editor. This is where we construct material nodes in order to define how the material behaves and is displayed, but we're not going to be creating any graphs. Rather, we are just going to be editing this thing right here, which is the result node. Now, to navigate around this window, we can simply hold the right mouse button to pan the screen around and zoom in with the scroll wheel. So here we have this node here, which has all these different things. And if you look closely, you'll see we have base color, metallic, specular, and roughness. These are the main things which are going to change the look of our material. So in base color, if we click on the little colored square to the right, this is going to open up our color picker. And what we can do is simply choose a color. So I'm just going to choose a red right here and click OK. And you'll see on the top left corner that material has changed. Now, if I go back to my test level here, you'll notice that the material has not changed on the sphere, and that is because whenever we make a change, we of course have to save it. So back in our material editor, simply at the top left corner, click Save This Asset, and that is going to save the changes. Now, if we go back to our level, we can see that this sphere here is red. But what else can we do to it? Well, we can make it reflective. To make it reflective, we simply want to change the roughness right here. And the roughness is a number between 0 and 1. A roughness of 0 means it essentially is a mirror, and a roughness of 1 means it is basically giving off no reflections. Right now it's at 0.5. If I bring this number down to 0, you'll see that our sphere is now very reflective. It is reflecting the background here. And then if I save this asset and then go back to my level, you'll see that the sphere here is going to be reflecting our environment pretty much like a mirror. We can then also change the roughness to 1 to basically make it not reflective at all. This could be something like wood or stone, whereas a low roughness would be used for things like polished surfaces or tiles. We also have metallic, and metallic defines how metal-like this object appears. Metallic value of 0 means it is not metallic at all, yet a metallic of 1 means it is going to have a very metallic surface. Now, it's a bit hard to see this effect if we have a low or a high roughness, so I'm going to bring roughness down to 0.5, and you'll see it now looks like we have this red steel ball. We also have specular, finally, and specular basically defines the intensity of the reflection. So if I set metallic to 0 and roughness to be 1, okay, roughness to 0, we will have a reflective sphere. Right now, our specular is 0.5, so it is around 50%. If I bring the specular to 0, have a look at the reflections. You'll notice that the reflections basically disappear. That is because specular defines the intensity of the reflections. If I bring it back to 0.5, you'll see we get back to normal. And if I bring it to 1, this is going to make the reflections even more vibrant. Okay, so a specular of 1 and a roughness of 0 is essentially going to be a mirror. And if I go back to my test level, there you can see it is reflecting the clouds, it's reflecting the ground here. It's a bit hard to see with a red sphere, so to make it more like a mirror, we can just set the base color to be black, and then save that, go back to our test level, and now you can see it is a very reflective sphere right here, okay? Okay, so between now and the next lesson, I want you to have a go at creating this golden material you can see on screen, okay? It looks like a big sphere of gold, so have a go at creating that and then apply it to a sphere inside of the level editor. Have a go at that, and I'll see how you're done in the next lesson. Alright, so I hope you had a go at that challenge. Let's now hop over into Unreal and have a look at how we can set this up. So what we're going to do first of all is I'm just going to select the sphere here, duplicate it, and move it over to the side so that we can see our material alongside our current one. Then what I'm going to do is open up the content drawer. Inside of our materials folder, I'm going to create a brand new material by right-clicking and going up to material right here, or you can go down to material here and select material. I'm going to call this one gold. Then what I'm going to do is just click and drag it onto the sphere here so it is already applied. Now let's double click on gold in the content drawer to open it up inside the material editor, and we can begin. So what I'm going to do is go over to base color, and I'm going to set this to be a nice gold. Okay, something like this, I reckon. There we go. But again, it doesn't really look like gold. It kind of just looks like a yellow bouncy ball or something like that. So what I'm going to then do is change the metallic. I'm going to bring this up to around 0.7, okay? We don't want it too metallic, as it's not really like polished steel or anything, as we're doing a bit of roughness in there still. So it's starting to look more like gold, but again, it doesn't really have that reflective property. So what we can do is go down to roughness and bring this to around 0.3. Let's have a look at what that looks like. There we go. That looks a lot nicer there. I might also bring the base color down in intensity a little bit, just so, not intensity, but maybe making it a bit more red, something like this, and there we go. So feel free to experiment with these settings right here. Also feel free to experiment with the details panel, looking at what happens if you change the different material domain, change the blend mode. For example, if I change the blend mode from opaque over to translucent, and then modify the opacity variable here to something like 0.5, we're going to have a see-through sphere right here. Okay, I'm just going to undo those changes. So I'm just going to now bring it back to a blend mode of opaque, as that is what we want. I'm then going to save this asset, and then if I go back to the test level, there we go. We have our gold material in-game. So you can use this for gold bars, you can use it for treasure that the player might want to pick up, pretty much anything you want. So yeah, that is a look at creating materials inside of Unreal. Hey everyone, in this lesson we are going to be looking at physics inside of Unreal. Now, when we're creating games, we might want certain things that interact with the physics engine. That means having gravity, collision, bouncing, that sort of stuff applied. So how can we do that? Well, here I have a little test environment set up. I basically just add in a cube as a ramp, and what we're going to do is add in some spheres to roll down. Now, what I'm going to then do is go over to my Place Actors window, go to the Shapes category and drag in a sphere. Okay, let's position it just above the ramp here so that when we play the game, it will fall. Now, you may be wondering, okay, we've got our sphere in the game, but how do I actually play the game? Well, to play the game, we want to go to the top and click on this play button right here, or Alt-P. That is going to play the game, and it is going to switch our level viewport over to our game camera. Now, where is this camera going to be placed? Well, by default, it is going to spawn in at the player start actor here. So, inside the outliner, you can select player start, and if you move this around, you'll see if I move it up here and then press play, it is going to have the camera spawn up here. So what I'm going to do is just line it up so it is facing the ball here. So if I press play, we can then see it fall down. But the sphere is not falling down. Why is that? Well, that is because we need to actually simulate physics on this sphere. Now, by default, actors inside of Unreal don't have physics applied because that can be an expensive process. So what we need to do is select our sphere, then go down to the details window here, and just underneath here you'll see we have a bunch of different categories: general, actor, LOD. General contains general information about this actor, which is of type static mesh actor, as you can see here, essentially a 3D model. So it has things such as its location, rotation, scale, as well as the mesh to render and material, which is generally the properties you want to modify on a 3D model actor. We can then go over to actor settings, which has these things here we don't need to worry about. But what we want to do is go over to physics. This is where we can enable physics and change its physical properties. So all I need to do is enable simulate physics right here and then press play. And what you notice is that the ball is going to fall down and roll. And if I fly around in the game view, which works the exact same way as if we're just in our level viewport, we can see this ball is just going to roll and then fall off the edge here. Now, you can then press escape to exit out of the game play, and that is going to return us back to the editor here. So what we now want to do is modify some of the properties, because right now, everything is kind of at its default. So I'm just going to bring this window up. You'll see here under physics in the details panel, we have simulate physics. We then have mass, which is sort of grayed out. And that is because by default, Unreal is going to automatically guess the mass of our object based on its size. So based on this sphere size, it is guessing our mass to be just over 100 kilograms. We can, of course, enable that and then change that number here to whatever we wish, but I'm just going to keep it on the automatic value. And of course, if you have a mass or two objects with different masses and they're both pushing against each other, of course, the object with the high mass is going to win. Then we have damping. We have linear and angular damping. Now, linear damping is essentially wind resistance or air resistance, okay? If you have an object that is moving across the ground, let's just say something is sliding down a hill, you might want to increase the linear damping to increase the drag that is applied to it. And angular damping is the same thing, but for rotation. So let's have a look. If I go ahead and press play and follow the sphere down, you'll see it is essentially just going to roll forever. And the reason why is because the sphere has an angular damping of 0. Essentially, it's not going to slow down over time. But if I change this to be, let's just say 10, and then press play, what you'll see is the sphere is going to roll and it's then going to slow down. And when it hits the ground, it's pretty much going to stop, okay? We can actually bring this down to maybe 2 and have a look at how that looks. So the sphere rolls down, it's going to roll across the ground, but it's not going to go too far because it has that angular damping. Essentially, its rotation is having drag applied. And if you don't want objects to roll or slide forever, it's recommended to add in some damping. I'm going to probably bring this down to 0.5. Now, we also have gravity, and of course, if we enable gravity and press play, well, this object isn't going to move because it is not affected by gravity. But if we were to duplicate this sphere, move it up, and enable gravity on the top one, we should see that this top sphere is going to fall, hit the one at the bottom, which is then going to bounce away as if it's in space. So let's have a look at what that looks like. And as you can see, there we go. The first sphere falls down, but this second one, since it doesn't have gravity, it is just going to fly around like so. And in fact, we can actually hit it with the camera to move it around in 3D space here, which in of itself could be a pretty fun game. But yeah, there you go. So we have physics here. Now, there are also many other properties that we can modify, but for now, just focus on these two right here, linear damping and angular damping, and perhaps even mass, okay? So for example, if you're wanting to have a crate that the player can kick around, you'd probably want to have a lower mass so the player can actually affect its position. If you have a ball that you want to kick around, you probably want to have a very, very light mass and an angular damping so the ball doesn't roll off forever, as we've seen here. But yeah, feel free to experiment with the physics, add in a bunch of different objects, maybe even create some cubes stacked on top of one another and watch them collapse. The physics in Unreal is pretty good, so you can definitely create some very interesting set pieces that, of course, can be fun gameplay elements in your future games. Hey everyone, in this lesson, we are going to be looking at lighting inside of Unreal. Now, lighting is a very important part of game development as it allows you to basically define how your game looks, okay? Lighting, like I said, plays a very important part in setting the mood and in guiding the player. So, here inside of our empty Unreal scene, we already have one light, and that right here is the directional light. Now, you can select it by clicking on the icon in the viewport, or you can go over to the outliner and select it here. You'll notice on the directional light that it has a white arrow pointing down and to the left here. That is essentially showing us the direction of the light, and this acts as our sun, okay? A directional light is a light that emits parallel lines of light in the same direction, okay? So, now what we can do is select the directional light, go over to the details panel and have a look at the different properties we can modify. So I'm going to select the general category here. And then if we scroll down to where we have the light drop down, we can see all the different properties for the light that we can change, such as the intensity. If I bring this up, you can see our environment gets brighter. But then when I let go, even though before we were at, 6 lux, and then I can bring it up to 130 lux, it kind of looks the same. And the reason why is because the camera that we have in Unreal is meant to simulate our eyes, okay? And our eyes adjust to different light levels, okay? The darker the light is, the more light we want to basically get into our eyes, and the more light there is, the less light our eyes try to get. So that's what is being simulated here. So this is good for example, outside you might want to have a bright sun, whereas inside you might want to have dim lights, okay? And the lighting will then adjust when the camera goes inside and out. We also have light color, which we can change by clicking on the color box and changing that here. So if you want to set up an environment, maybe you have a sort of sewer or something, that sort of level, you might have a green tint. If you have something in space, you might make it more dark bluish. It's really up to you how you want to set this up. Another property that you might be interested in modifying is the temperature. Now, light in the real world, we measure it based off color temperature, okay? And a color temperature is basically how cool or how warm a light is. Right now, our temperature is around in the middle, which is sunlight. If we bring the temperature down, you'll see the light gets a lot warmer, okay? And this is what you would be using for candles or fire. Whereas if we increase the color temperature, this is what we'd be using for more modern day LEDs or fluorescent lights, okay? So depending on what sort of light you're trying to simulate, you might want to look online. For example, if you want to have a candle, you might want to look online, okay, what is the intensity or the lux that a candle emits? What is the color temperature a candle emits? So that you can try and get it as accurately as possible. If you have a light that you don't want to actually be working or casting light, you can disable effects world, which will of course make our entire world dark, and we can also enable or disable shadows. It's a bit hard to see, but if I go ahead and add in an actor here, let's add in a I just need to go down here, go to shapes, drag in a cube right here, move it up a little bit, and then if I select the directional light again, and then in the details panel, I can go over and disable cast shadows. You'll see that the cube is no longer casting a shadow, okay? So if, for example, in your scene, you don't want shadows being casted, or you've noticed that performance is being impacted by all the shadows, you can disable that for some lights. Now, we don't just have directional lights. There are also many other different light types we can use in Unreal for different purposes. For example, let's go over to Place Actors, and then we'll go to our lights panel, and you'll see there are 5 different types. We have directional light, point light, spotlight, rect light, and skylight. Now, we already have a skylight inside of our level, so if I go back to the outliner, you'll see here we have skylight, and this right here is basically emitting the light that we have from our atmosphere and from our skybox, okay? So for example, if our skybox was some sort of reddish environment, then our surface down here would have a reddish tint to it, okay? Generally, the skylight, we don't really touch that much as it generally does its own thing, but we also have many other lights that we can add to our game. For example, a point light. Let's drag the point light in, and it may be a bit hard to see, so what I'm going to do is select my directional light and actually go ahead and disable it, so toggle effects world. So now we have our point light here, okay? And the point light is essentially a light that emits from all directions around it, okay? So this is very good for things such as candles. Maybe you have a light bulb that you want to emit light everywhere, a fireplace. That is a good use case for a point light. And if we wanted to make this look more like a candle, we could go ahead and change the color temperature, which as you can see is currently grayed out. And the reason why is because some lights by default don't have temperature enabled. We can simply enable use temperature and then bring that down to something like this. So now you can see we have this nice little candle light. It's still probably a bit too bright, so what we can do is go here and just lower this intensity a little bit. So now it looks like we have a bunch of candles around the place, and I can go ahead and duplicate them like so. Now with the point light, we can also change its range. I'm just going to delete these ones we don't need here and move this one over here. You may notice there is this big circle around our light, and this is showing us the attenuation radius, or basically the maximum distance the light can go. You'll notice here in the details panel, if I increase the attenuation radius, it is going to change the maximum range at which the light can go. But you may notice it doesn't really do much. In this case, we have to increase the intensity as well. And you'll see if I increase the intensity all the way up to max, it is not going to go beyond the bounds of this radius. And I can bring the radius back down. And as you can see, it is basically clamping to that range there. Now, what other light can we add to our game? Well, if we go to place actors, you'll see we have a spotlight. I'm going to drag that one in, and I'm going to delete our point light just so we get that out of the way. Now, a spotlight. If I bring this up a little bit, you'll kind of see what it does. It essentially casts light in a cone, okay? And this is really good for something like a torch or a street light or car lights that you want to emit outwards. So that is generally what you'd be using spotlights for. Or if you want to highlight a specific point, maybe if you have a stage and you want to highlight the stage, you can do that like so. With the spotlight, we can go down into our details panel and change stuff such as the angle of the inner core, which determines basically the maximum brightness of the light, which then at the outer core angle determines the fall off distance. So basically the light is going to fade out to the edge, and it's going to begin fading once the inner core once the light has reached past the inner core. So you can see here, if I change the inner core, the light only starts fading away at the edge of that. We can also change the outer core angle as well if you want a very wide spotlight or a very shallow spotlight, something like this. Maybe if you have a stage, you might want something like that. We can also change the light color, just like with before, to whatever we wish. And yep, that is our spotlight. Now, the one final light we have is going to be our rect light. And the rect light, you may be able to guess what it does. It essentially emits light in a rectangular shape, okay? So this can be very good for LED panels, or maybe if you just want a soft light bathing across a scene, you could shoot a rect light at it. So I'm just going to rotate it down. As you can see, we have this little rectangular shape, which shows basically the size and area it's going to cast in. Let's move it over here a little bit. We can change properties, for example, down here, such as the source width, which changes how wide that light is. So if I stretch this out, you can see the light becomes very wide. We can also then change the source height. So if I shrink this down, it's now going to be this very thin light beam. You may also notice this thing right here, the barn door angle. This essentially is going to dictate how the sort of angle that the light is going to emit from the box. Right now it's 88 degrees, but if I bring this down, you can see it is going to sort of clamp that light so can be a very narrow beam, or it can be much wider. Okay, so it really gives you the ability to adjust how exactly your light is going to behave. Same thing for the length as well. Okay, so you can adjust both these settings to fine tune how the rect light is going to behave. So that is a look at the main light types inside of Unreal. Feel free to experiment with them, as there is a lot you can do with lighting in an engine like Unreal. So feel free to experiment with the different light types, try mixing them together. Even try experimenting with the light settings down here, and just if you see something you don't understand, simply just hover over the property and it will give you a little description on what it does. And just, toggle the buttons, move the values around just to see what happens. So, thank you for watching. Hey everyone, in this lesson we are going to be looking at creating blueprints inside of Unreal. Now, what is a blueprint? Well, essentially in Unreal, we have all of these different actors, and we might, for example, want to have an actor that is duplicated many times. For example, a tree, or we might want to have an enemy character that can chase after and attack the player. Now, we could of course do this by creating a bunch of those objects. Let's just say we want to create a rock. So I'll go to my place actors, go down to shapes, and let's just say we want to drag in a bunch of these spheres, okay? So we'll get these spheres here. We can then duplicate them around like so, and we'll then have a bunch of these rocks in our game. Now, let's just say we want to all of a sudden change the look or the behavior of one of these rocks. Let's just say we want to change the material to be gray. Well, what we'd have to do is we'd have to apply the material to this one, then to this one, then to this one, then to this one, then to this one. And that could be quite cumbersome if we have hundreds or even thousands of these rocks in our level. What if we want to change the size of a rock? Well, we'd have to change the size of this one, select the next one, change the size of that one, so on and so forth. Now, what blueprints allows us to do is to create basically, well, a blueprint of an actor. And then we can create instances of those actors inside of our level. And then whenever we make a change to the blueprint, that change gets applied to everything. So what we're going to do is I'm just going to delete these spheres we've created right here. And I am going to open up the content drawer with Control Space. And then I'm going to create a new folder. I'm going to call this folder Blueprints. And inside the Blueprints folder, we want to create one. So I'm going to right click. And if we go to the top here, you'll see we have a Blueprint class. Okay, we're going to select that. And it is then going to ask us to choose our parent class. This essentially is going to be the root of this blueprint, or the root of this new actor, because what we're creating here essentially is an actor, but with more complexity. So there are many different parent classes we can choose from, and these aren't the only ones. We can click on all classes here and go through the entire list. Okay, there are many of those in Unreal. So we can create one such as an actor, which is essentially just the most basic form. There is no added behaviors at all with this one. We have a pawn, which could be used for characters or the player controller to move them around. Character, which is a derivative of pawn. We then have player controller and a bunch of others here. What we're going to choose is actor, okay, the most basic form of blueprint. And then I'm going to rename it. And I might call this one, let's just say lamp post. Okay, so let's just create a little lamppost blueprint. Now, to open up the blueprint, we simply need to double click on it, and this is going to open up a brand new editor called the Blueprint Editor. Now, clicking on the tab at the top, I'm going to dock it next to my test level here. And inside the Blueprint Editor, it's going to look similar but different to our level editor. In the center is where we have our not level viewport, but just our blueprint viewport, where we can basically control it the exact same way as we can inside of our level editor. On the right-hand side, we have a details panel, which when we select an object, this is going to show us all the details for that. On the left-hand side, though, it's a bit different. We have a components window and a My Blueprint window. Now, components, these are essentially the building blocks, the entities that construct, that make up our blueprint here, because a blueprint can be made up of different actors, different components, all different bits and pieces. For our lamppost, for example, we are going to have some 3D models to act as the post, the lamp, and then we're going to have a light that emits outwards. And then down here is the My Blueprint window. Now, this is for when we start getting to the visual scripting side of things, okay? When we start looking at constructing logic for our blueprints, which we're going to do in a future lesson. So let's go over to the components, and you'll see we already have two components. We have a lamppost self. This is essentially the root or the parent of this blueprint. Okay, this is the thing we'll be moving around inside of our level. Then we have a default scene root. This is essentially the root, I guess you could say, location of our blueprint when it's placed in the game world. So these are the two things we're going to have by default. But let's add in our lamppost. So I'm going to click add right here, and you'll see we can add a bunch of different components. I am going to go down, actually I'm just going to search for cylinder, and we can add that right here. So there we go, we have a cylinder added in. I'm then going to shrink it down and then maybe stretch it up vertically like so. Maybe move it up a little bit so it's sitting on the ground. You can see the grid right here has the ground there. Then what we can do is create a little bulb up here for the light. So I'm going to create a sphere. I'm going to move that up to the top here. We can also rename these components. So I'm going to right click on sphere and then go over to rename. I'm going to call this one light bulb. And then for the cylinder, I'm going to rename this to call this the post. Then we need a light component. So I'm going to add in a point light right here and drag that up to the center of the sphere. So now it is going to emit light outwards. And let's actually go to the details panel now with our light selected, and I'm going to enable use temperature. I'm going to bring the temperature down a little bit, and I'm also going to bump up the intensity here. Now, it's hard to see because we don't really have an environment for the light to shine upon. Then let's go back over to our test level. Now, inside the test level, let's open up the content drawer, and you should see here the lamppost blueprint now has an icon. So we can simply click and drag that in and place it like so. Now, to see the light better, I'm actually going to select the directional light and just disable effects world so that we can see our lamppost in action here. And as you can see, there it is. We have our lamppost working as intended. Now, let's go ahead and duplicate this one a bunch. So I'm just going to drag this over here, make a copy over here, so on and so forth, okay? Now, we got our lampposts in our game, and you might have hundreds of these perhaps. But what happens if I want to change all of a sudden the light color? Well, I'll have to select this lamppost here. I can then go down to the details panel, and you'll see here, just above where we have all the properties, we have a list of all its components, okay? You can see we have the post, the light bulb, the point light. So what I can do is select these individual components for this actor here, and then I can modify them. So I might want to increase the temperature to a much cooler color, and then I could do that for all of them. But if we have hundreds of these lampposts, that is going to be a very tiresome process. So instead, what we can do is simply modify the actual blueprint. If I go back to my lamppost blueprint and change the light temperature to be very cold here, save that, go back to the test level, now you'll see that that change has been applied to all instances of the lamppost. Now, how do we know if an actor in our level is a blueprint? Well, if we go to the outliner, you'll see here on all of our lampposts, we have on the right-hand side a type category. Now, the type category is going to be different for all of these actors. Basically, this is just showing what type of actor it is. For example, our floor is a static mesh actor. Our directional light is, of course, a directional light. And our lampposts are lampposts. And we can actually click on Edit Lamppost right here to edit that blueprint. So that is how we know it is, in fact, a blueprint. And any change we make, if we want to make the bulb here, let's just say we want to make it very long in this weird shape, save that. That is going to be applied like so. So this right here is how we can use blueprints inside of Unreal to essentially make our own custom actors that we can then create instances of inside of our level, and any changes made to the original blueprint get applied to all instances. But we can also go ahead and modify the individual instances here. So I can, for example, change the light bulb scale here, but that is not going to affect any of the others. Only when we affect the blueprint do those changes get applied to everything else. So that is a quick look at blueprints inside of Unreal. Hey everyone, in this lesson we are going to be looking at visual scripting with blueprints in Unreal. Now, we looked at a blueprint already in the previous lesson, but what is visual scripting? Well, essentially, we can have blueprints, which is essentially a template for an actor, which we can then create instances of in our level, such as rocks, enemies, or pretty much anything that you want multiple of, or that you want to apply certain behaviors to. Well, visual scripting is those behaviors that we can then apply to actors. For example, if we have a player character, we will have visual scripting that detects inputs and then moves the player around. If we have an enemy, we would have a visual script that tracks the player's location and moves the enemy towards them to then attack. Okay, this is essentially coding, but in a visual format using nodes and connecting lines between them. So you don't need to have any knowledge of programming to get into visual scripting. Okay, so let's get started. We're going to start by creating just a basic blueprint, which is just going to have a cube, and then we're going to look at different behaviors and stuff to apply to it. So inside of our content drawer, let's create a brand new blueprint class. It's going to be of type actor, and I'm just going to call this one test. We'll call this one test cube. Now we can double click to open it up, and it's going to create a new tab here. Let's start by just adding in a cube like so, and that's about all I'm going to do. So I'm going to save this editor here with the save button, go back to the level editor, and drag the test cube in. Okay, so you should see now that here in the outliner, we have our test cube blueprint instance added to the level. Now, let's go back inside the test cube blueprint editor. And at the top of the screen here, you'll notice that we have a couple different tabs. We have our viewport, which we're in right now, which is this little window we can look around and edit our objects. We then have construction script and event graph. What we're going to do is select event graph, and this is going to take us over to our blueprint graph right here, where we can create nodes and connect the logic up. Okay, so the basis of visual scripting is using nodes. A node can do many different things, and there are hundreds of nodes, okay? Nodes can be triggered when certain things happen in the game. For example, this event begin play node, which we can see right here. This gets triggered at the start of the game when this blueprint is first spawned in. So if you want to have any initialization logic, such as setting values or the like, you can connect that from here. Event actor begin overlap. This node gets triggered whenever we enter the collider of another actor, and event tick gets triggered every frame. So these are the starting nodes we have, as these are the most common starting points. Now, you'll see right here it says right-click to create new nodes. If I go ahead and right-click, it is going to bring up this little window here with all of these node categories, and inside of them they have all their different nodes. There are hundreds and hundreds of nodes for us to choose from, and each of them do a specific thing. Now, we're going to keep it very simple. Right now, I'm going to right-click, and I'm going to search in the search bar here, print. And you should see we have a print string right here. I'm going to click on that, and it is going to create this node. Now, when I hover over the node, you'll see my mouse cursor changes, and we can click and drag to move it around. We can also zoom in and out of the scroll wheel and hold the right mouse to pan the screen around, okay? So, here we have the print string node. Now, what does this do? Well, if we hover over it, it says print a string to the log and optionally to the screen. Now, what is the log? Well, when we run our game, we have the console or the output log, which is essentially this thing down here. If I click on it, you'll see it opens up. And this right here is basically outputting information that may be useful for us. If there are any errors in our project, that will be displayed here. Or in this case, we can print a message to the output to basically know that the blueprint here is working correctly. So, if we were to go back to our test level and press the play button at the top of the screen, you'll notice that nothing happens. And that is because for two reasons. First of all, if we go back to our test cube, we need to actually connect this node up to something, because right now this node doesn't really do anything, okay? It's just existing on its own here. We need to connect it to the execution flow. This, you can think of it like electricity. You have something that is energized, and it passes on that current through wires into other things, that passes on the current into other things, okay? And that's essentially what we're doing here. Now, we can connect this print string up to one of these nodes or multiple of these nodes. These red nodes with the red banner at the top are event nodes, and event nodes are things that get triggered or invoked. Like I mentioned before, the begin play node gets triggered once at the start of the game. So what we can do is connect this to our print string node. So at the start of the game, this print string node gets triggered. Now, how do we do that? Well, you'll see on the nodes here, we have these little white arrows, okay? And this is the execution. Basically, when the begin play node is triggered, it is going to execute whatever node is connected to or from this output here. So what we can do is click and drag on that and connect it to the opening or the input from the print string here. Now you'll see there is a white line between begin play and print string. This means that when begin play is triggered, it is going to basically go to whatever node is connected to and basically run that node. In this case, it is going to print the string hello to the output. So now if I save this and go back into test level and press play, you'll see it says hello at the top of the screen here. Or if I open up the output log and scroll right down to the bottom, you'll see right here, our test cube has said hello. Okay, so that is how we can connect nodes up in visual scripting. So I'm going to stop pressing play, go back to test cube here. If we want to change what the message is, you can see on our print string node, we have the in string here, and here we can simply change it from hello to say whatever we want. So here we could say Zenva, and then if we save, and then also click compile up here, okay? Whenever we add or change nodes, we want to click the compile button, which essentially converts these blueprints into readable code that the computer can then run. So then we can go back to our test level, press play, and here at the top left corner, as you can see, a message appears. Now, we can also choose to connect this up to another node. If you want to delete a connection between two nodes, simply right-click on either side of the execution flow and select break this link. Now, if we drag the node down here and connect it to event tick, this print string is going to be triggered every frame. So if we save, compile, go back to our test level and press play, you'll see every frame, this message is now being printed to the output. And if we open up the output log, you'll see it's there as well. So there we go. That is the basis of visual scripting. Let's just go over the basics one more time so you have a better understanding. in visual scripting with blueprints, we have nodes, okay? All of these things here that we can move around are nodes. And nodes will have inputs and they will have outputs. You can see on the left-hand side, on some nodes, they have things that we can connect to. These are inputs. These can be inputs such as the execution flow or inputs such as text here as a string. You'll see the event tick node has outputs, okay? It has the execution output, so basically once this node has been triggered, it will run whatever node is connected to this. And it also has a delta second output. This is essentially the time between frames, so if you want to know exactly how fast the frame rate is, you can connect to this value. And you'll also notice on print string, it actually has an output execution node as well. So we can then connect this off to another node. So once print string runs, it can then call and run another node. And that is essentially how visual scripting works. We are chaining together nodes in a particular order to accomplish a certain goal. Now, in the next lesson, we are going to be looking at variables. So thanks for watching, and I'll see you all then. Welcome back, everyone. In this lesson, we are going to be looking at variables. Now, a variable is essentially a piece of data that can be stored on our computer, okay? And then later on, we can read this value or we can modify it. Now, variables can be anything, essentially. If you want to keep the player's score, that is a number you want to keep track of, you would keep that as a variable. Then whenever the player gets a point, you would increase that score. Whenever you want to display that score on screen, you would read that variable. Likewise, variables could also be used for the player's health, determining how fast or how slow they move, how high they jump, what weapons they have currently equipped. These are all variables that we can create and use. So how do we create variables here inside of visual scripting? Well, what we want to do is go down to the bottom left corner where we have the My Blueprint window, and this shows us a number of different things. It shows us our different graphs, which is essentially this window right here. This is our event graph, which is basically all of the visual scripting that is running for this blueprint. And inside of here, we can see the different event nodes we have already placed. And then we have variables. Now, I'm going to click on the plus right here to create a new variable, and we can give it a name. Let's create a variable that keeps track of the player's score. So I'm going to call this one score. Now, you'll see also next to the name, it has this thing called boolean, and it has a red little icon here. This is the variable's data type, okay? And each variable has a specific type, okay? You can have variables that keep track of numbers. You can have variables that keep track of text. You can have a variable that keeps track of an actor or a component or a light, or a variable that keeps track of pretty much any different type of thing. If we go over to the details panel with that score variable selected, you'll see a much more in-depth view of the variable. We can change its name, or we can change the variable type. If we click on the variable type dropdown, you'll see there is a large list here. We have boolean, which is true or false values. But for a score, we want to have a whole number, okay? Things like 1, 2, 3, etc. So for that, we would use an integer, and an integer is essentially a whole number. So we'll click on integer here, and here we can basically change some of the values, okay? We can give it a description so we know exactly what this variable does. We can then also change other things, such as the value range. So is the minimum and maximum number this score variable can be, and so on and so forth. But what we want to do is use this variable inside of our blueprint here. So what I'm going to do is make it so that at the start of the game, we are going to print out the value of score. So what I'm going to do is first of all disconnect the print string node from event tick by simply right-clicking on the output or input execution node and click break this link. Then I'm going to drag it up here just so it's closer to begin play and connect that up. So now at the start of the game, this is going to be printed, or this print string node is going to be triggered once. Now you'll see here we have an input here, and you'll see it is pink, whereas the one down here in delta seconds is green, and the one here in actor begin overlap is blue. That is because Unreal likes to color code its different variable types, and what you're seeing right here are inputs and outputs that either output a specific type of variable or require an input of a specific variable type. Delta seconds down here, for example, if we hover over, is a variable type of float, which is a decimal number. Other actor here is blue, which is of type actor. And print string has a pink input, which is string. And a string is essentially text. So if we go back to our score variable in the details panel, you'll see here, if we go down and look at string, that's pink. If we go to float, that's green. So all variable types inside of Unreal are color coded. So after a while, you can just have a quick glance at an output or an input here and go, okay, that is a float, that's an actor, that's a string. Now we want to have our score be printed out, okay, instead of this Zenva or hello string. So how do we do that? Well, first of all, we need to add our variable as a node to the graph here. And to do that, we can simply click and drag on it into the graph and let go. Now we'll have an option. Do we want to create a getScore node or a setScore node? A setScore node is a node that changes the value of score, whereas getScore is a node that basically outputs its value. I'm going to go getScore, and we have this little node right here, okay? And all this node has is a little bit of an output. So what we can do is click and drag on this integer output and connect it to the string output. And you'll see when I hover over the in string, it's not going to connect to it directly. Instead, it is going to create a conversion node. And if I let go, you'll see we have this new node created right here. And this is a conversion node. Essentially, it takes an integer input, converts that to a string, and then outputs it here, okay? Because we cannot connect an integer to a string. That's not possible. So we need that conversion node here. So what's going to happen at the start of the game is this begin play node is going to trigger. It's going to send the execution flow through this white line into the print string node. And this print string node is going to essentially print out this input right here. Then what the program is going to do is going to look at the input and go, okay, in string is connected to this node, which converts an integer to a string. And it's going to run the logic in order to basically get this correct input here. So if we save and compile, then return back to our test level and press play, we should see at the top left corner, it says 0. Now let's change the value so we can actually see if it's working. Back in our test cube, I'm going to select the variable here in the My Blueprints window. And then in the details panel, I am going to go down to where we have the default value right at the bottom here. And I'm going to change this to be, let's just say 1078 or 178. Okay. We then need to save, compile, go back to our test level. And if I press play, as you can see, it says 178 right there. I can press play again to make sure you see it. And there we go. So that is how we can read a variable inside of Unreal. And this is great. If ever we want to basically update our screen to display the current player's score, we can simply read from the variable node right here. But what happens if we want to change the score variable? What if the player collects something and we want to increase their score by 1, or if we want to multiply it by 2, or if we want to cut it in half? How do we do that? Well, in the next lesson, we are going to be looking at just that. But before then, I want you to complete a challenge. I want you to go ahead and create a brand new variable, and I want you to call it player name. I want you to set the variable type to be string, and then I want you to give the default value something, okay? Maybe give it your name, for example. Also, if you don't see the default value down here, simply compile the blueprint, and then that default value should appear for you to edit. And then finally, connect it up to the print string node so that it outputs the player name. Okay, just as a bit of a challenge. So thanks for watching, and I'll see you all in the next lesson. Okay, so I hope you had a go at that challenge. Let's look at how we can set that up. So what we're going to do is go down to our variables list and create a new one here. And I'm going to call this player name. Now over in the details panel, I'm going to change the variable type from integer over to string, which is essentially text. And you'll see here it says, please compile the blueprint. If I go ahead and click compile, that is then going to allow us to enter in a player name, which I'm just going to say something such as Tom. Okay, just a simple name. Then what we can do is go back to our event graph here. I'm going to delete these two nodes here. So I'm going to select a node and press the delete key on my keyboard. Same thing for the score. And then drag in player name, select get player name, and connect that to the in string input here. Now, if we save and compile that, then go back to our test level and click run, we should see that we have that name being printed out here. Okay, so we have that all set up. Now let's look at how we can actually start changing the value of our variables. So I'm going to go ahead and delete player name and delete the print string node here, so we have nothing left. In fact, let's clean this up a little bit. Let's also delete the actor begin overlap node and event tick. And we're going to keep begin play. Now, if you accidentally delete begin play, simply right click and search for begin play, and you should see event begin play right there, and you can create that here. Okay. Now what we're going to do is go to our score variable and drag that in, but instead of selecting get score, we're going to change it to set score. Now this variable looks a bit different. We have both an input and an output execution flow. So I'm going to connect the begin play node to the set score node here. And then from set score, we can of course connect that off to something else. But for now, what does this node do? Essentially, this node changes the value of our score variable. So essentially what we're doing here is at the start of the game, begin play is going to be triggered. The execution is going to flow into the set node where it is going to set score to be equal to 0. And then that variable's value is going to change and it's going to continue on with the execution. So what we can do here is enter in any number we want. Let's just say we want it to be now 1000. And that is going to change the value of that variable. So what we can then do is add in a print node here, print string. Move it onto the right hand side here and connect the output execution into the print string's input execution. So what we're doing here is chaining up nodes. Essentially, when begin play gets triggered, that is then going to trigger the set node, which is then going to trigger the print string node. So we can then connect the output of the set, which is going to be the new value of our variable, to the in string. That's going to create that conversion node, which we can drag down here. So what we should see is if I save, compile, and press play, we should see the number 1000 appear on screen, which it does. Okay, so that is how we can change the value of our variable. And the value of our variable can change across the blueprint as well. Okay, so for example, if after we set the variable and then print it, let's set it again. Now I'm going to show you another way of adding a node. We can just go to the output of the print string, drag out and let go, and here we can enter in a node name. So I'm going to go set score, and you should see that pops up here. And that is going to automatically connect that node like so. Then what we can do is change the score value here. Let's make this 5200, and then we can connect this up to another print node and connect that like so. Okay, so what we're doing here is essentially changing the score, printing out that value, then changing the score again and printing out that value. So we should see two things being printed out. Can you guess what that is going to be? Let's save, compile, go back to our test level and press play. And as you can see, it says 1000, then 5200. Let's press play again. Also, the number on the bottom is the oldest, okay, because the numbers get added on top. That is why 1000 appears below the 5000. Okay, so that right there is a look at changing our variables. Now in the next lesson, we are going to look at how we can start modifying these variables a bit more, because right now we're just hard coding the values. We're setting score to 1000, we're setting score to 5200. But what happens if we want to increase the score by 1 or increase it by 10 or cut it in half? How do we do that? Well, we are going to be looking at operation nodes in the next lesson. So thanks for watching, and I'll see you all then. Welcome back everyone. In this lesson, we are going to be looking at operators inside of Blueprint scripting. So what I'm going to do is just drag in my score variable, select set score, connect this up to the begin play node, and then connect this to a print node so that we can then output the value here, okay? The similar setup to as we done in the previous lesson. But instead of hard setting the score here, we might want to increase score by 1 or increase it by 5 or 10 or something like that. So if we select our score variable here, I'm going to go to the details and set the default score to be 0, just so it's going to be easier to see the change, okay, and compile to save those changes. So now if we were to go back to our test level and press play, we should see 0. Okay, Now, how do we add 1 to our score? Well, what we're going to do is, first of all, drag in the score variable again and go get score, because in order to increase it, we need to know what the original score is. Then what we're going to do is drag out from score and connect this to a node called add. Okay, type add and then hit enter. This is going to create an add node. Basically, we give it 2 inputs, both of these being integers. It's going to add those 2 numbers together and output the result. So what we want to do is add our current score to another value. Let's just say we want to give the player a plus of 1. So enter in plus there. And then the output, we're going to drag to the set score input. Now, if we save, compile, and press play, what you should see happen is our score is 1. It's a bit hard to see because our score is 0 and we're only increasing it by 1. So let's maybe change this to increase it by 20. Now what we're doing is increasing our score by 20. And in fact, to make it look even, to make it more obvious that we're adding and not just setting the score, let's select the score variable and set its starting value to be 100. Okay, so what we're doing here is we have a score of 100 and we are adding 20 to it. So if I compile, save, go back to our test level and run, you should see it says 120. To get a better understanding of this, let's actually connect this not to the begin play node, but to the tick node, which gets called every frame. And I'm going to create the event tick node right here. And I'm then going to delete the connection between begin play and set and instead connect that to tick. So now every frame we are going to increase the score, let's just say by 1. Okay. And I'm going to set the score here back to be 0 at the start, and we're increasing it by 1 each frame. So when we press play, we should see that number going up very quickly. And as you can see, it's going up 100, 200, 300, 400. Every frame, we are adding 1 to our score and printing out the value. So that is how we can do addition. Alternatively, we can also do subtraction. So if we delete the addition node here, we can connect score into a subtract node, which is going to do the exact same thing, but with subtraction. So we have our score, and then we might want to minus, let's just say -2. So every frame, we are going to subtract 2 from our score. Let's compile that, go back to our test level, run, and now, as you can see, it's going into the negatives. We can also do multiplication. So we can connect this up to a multiply node. And likewise, this is going to do the exact same thing. So if I make this 2, for example, save, compile, and then run, nothing's going to happen because we are basically multiplying 2 by 0. So let's set our starting score to be 1. And then if we go ahead, compile, save, and then run this, you should see our score is going to increase by 2 or multiply by 2 each frame. And you see quickly, it'll go to 0. And that is because integers have basically a maximum number before they flip back around to 0. So that's why it quickly goes to 0. But as well as multiply, we also have divide. So we can plug this into a divide node where each frame we might want to divide by 2, for example. That's going to work exact same way as all the others. So yeah, that is just a look at using operators inside of visual scripting for our nodes right here. Okay, so as a bit of a challenge, what I want you to do is connecting from the begin play node, I want you to set the score to be 10, then print out the value. Then I want you to half the score and print out the value. Then I want you to triple the score and print out the value. So have a go at that, and I'll see you all in the next lesson. Alright, so I hope you had a go at that challenge. What we first of all want to do is set our score to be 10. So I'm going to drag in the score variable here, go set score, set this number here to be 10, and then connect that up to the execution flow from begin play. Then we want to print out that value. So we'll just connect it up like so. We can also compact these nodes together so it takes up less space. Then from this print string node, we are going to plug this again into a set score node, but this time we want to half the score. And to do that, we are going to get our score, so drag it in, get score, and then connect this up to a divide node and plug that in to score here. Oops, we'll just bring this over so it's a bit more compact, and we want to divide by 2. Then also printing out the value. So I'll plug this into a print string node and connect it up like so. Okay. And then finally, what we want to do is we want to triple our score. So we'll plug this into a set score node. We want our score to be our current score multiplied by 3. So we'll plug this into a multiply node, multiply that by 3, and then connect that like so, okay? And then finally, we want to print out that value. And what we should have now is this node tree right here. And when we press play, we should see 3 numbers being printed out. So I'm going to save, compile, go to our test level, and press play. And what you'll see is 10, 5, 15. Let's press play again. 10, 5, 15. So from here, I recommend just experimenting with creating variables and changing them over time, printing out the values to make sure that they work correctly. You can even try adding 2 variables together, okay? We could create another variable here, maybe called gem or coin amount, and instead of just increasing score by an arbitrary value, you can plug another variable into the other input here to increase score by that amount, okay? There are many things you can do with variables, so have fun and experiment with those. But for now, I'll see you all in the next lesson. Hey everyone, in this lesson we will be looking at conditions in Blueprint visual scripting. So far we have looked at setting up our blueprints by basically connecting one node to another, and it basically executes those nodes one at a time. Now that's good if you want a specific set of instructions to run, but what if you want to check to see if something is true or false? What if you want to check to see if the score is equal to 100 or if it is less than 10? And you can then do different things based on those. Well, that is where the branch node comes into play. I'm going to right click here and create the branch node. And this, as you can see, has an input, as does, well, every other node. So we can drag and drop that in like so, but it has 2 output execution nodes, true and false. Basically, it has an input, which is a condition, and this is a boolean, and a boolean is a variable type that can be either true or false. So whenever you see this dark red variable type, that is true or false. And if that condition is true, then the execution flow will exit out of true and run whatever nodes it's connected to. Or if it's not true, if it's false, then the false output will execute. So you can see here how we can start to branch our node tree here. So what can we do for the condition? Well, let's just say we want to check to see if the score is equal to 100. If the score is equal to 100, that means the player has won the game, and we can then run the credits or whatever. Otherwise, we're going to keep playing. So I'm going to drag in the score variable and go get score. And what we need to do is check to see if score is equal to 100. So how do we do that? Well, let's drag out from score, and we want to put this into an equal node right here. Okay, you'll see equals, and then in brackets equals equals. Create that. And here, basically, we're checking to see if A is equal to B. A is the current score, and B, we can enter in 100. And then with this, we want to plug the output, which is of type boolean, into the condition here. Now, once this branch node runs, it is going to check to see if score is equal to 100. If it is, then true will execute. Otherwise, if score is not 100, then false will execute. So I'm just going to add in a print node out from the branch here, which says win if it is true. Otherwise, if it's false, we will print string, and here we'll just say keep plain. Okay, like so. Now, let's select our score node here, or our score variable, and set its score to be 100. Now, if I save this, compile, and then go to play my game, we should see that it says win at the top left corner. But if I were to go ahead and change the score to be something such as 90, and then compile that, save, and press play, it says keep playing. So branch nodes are great as they allow us to branch our nodes, essentially, as it says. And you can hover over to get a much better understanding as well. And if you want an even better understanding, you'll see it says hold Control-Alt for more. Hold down those 2 keys and it will give you a much more in-depth explanation on how this node works. And you can hover over any node to get a better understanding of what it does and how it works. So we've got this set up. Now, not only can we check to see if one value is equal to another, we can also check to see, for example, if score is greater or less than a certain number. So I'm going to go ahead and delete the equals node here, and instead plug score into a greater than node. Okay, and we're going to put that into the condition here. Now what we're going to do is check to see if score is greater than 99. What this will mean is if the player's score is 100 or above, they will win the game. Otherwise, if it is below, so if it's 99 or below, then they're going to keep playing. Okay, so this makes it so that any number above and including 100, we will trigger that as a win. Now, there's a very similar node, which is the greater than or equals to. So we can plug that into a greater equal node right here. And this, we can basically just give it the value 100. This is going to output true if score is greater than or equals to 100, okay? So there's a little difference between the greater than and greater than or equals nodes, but they pretty much work very similarly, okay? Except for one also checks to see if it is equal to. Now, as well as this, we also have the less than and less equal nodes, which do the opposite. And if we just simply search for operator, you can see all the different operator nodes we can have. So here we have less than, greater than or equals to, not equals, which checks to see if score is not equal to a certain number. So feel free to experiment with these, as you can definitely create some branching code, and that is then how we create more variance in our gameplay. For example, we are only going to move the player if the move button is being held down. So thanks for watching, and I'll see you all in the next lesson. Hey everyone, in this lesson we are going to be looking at events in Blueprint scripting. So we have already been working with events, okay? This red node right here, and you can tell a node is an event when it has a red banner, is the begin play event node. And an event node essentially is a node that triggers the execution flow. So the execution flow is the white line that exits a node and plugs into another. You can think of it like an electrical cable you can plug into devices. An event node gets triggered when a certain thing happens. Okay, if we hover over the begin play node, you can see event when begin play for this actor. So essentially, the first frame this actor is in the game, this begin play node gets triggered. We also have the event tick. So if we create the tick node here and hover over it, you can see event called every frame. So this is basically what we want to do. If we want to move something every frame, this event node is going to be triggered. But we can, of course, create our own custom event nodes. Now, why would you want to do this? Well, let's just say we want the player to be able to add their score, okay? We don't want to create custom nodes and everything for every possible way of adding the player's score. For example, if the player collides with a pickup, then of course we want to add their score. If the player defeats an enemy, we want to add their score. But we don't want to basically set up those nodes in separate areas, okay? If we are having nodes that do the same things over and over, it's good to sort of combine them into a single event that can just be called once. So I'll show you what I mean. I'm going to right click and simply type down custom event, and you should see add custom event. And that's going to create a new event node. We can go ahead now and give it a name. I'm going to call this one add score. And from here, what we can do is basically just create nodes, and we can then invoke or call this add score node. So from add score, I'm simply going to print, and here I'm just going to say add score. Okay, nice and simple. This is all we're doing here. Now, how do we actually call or run this add score event node? Well, we need to invoke it or call it. And to do this, we simply go up to begin play, where it's going to be the easiest way of doing this, drag out, and we simply type add score. And this right here is going to trigger that add score custom event. So now if I save and compile and go back to our test level to press play, we should see it says add score at the top here. So that right there is a custom event. Now, we can actually have this add score event have inputs, so we can give it values that it can then use. So I'm going to delete print screen here, and then I'm going to select the add score, because what we want to do is essentially increase our score. So let's drag in the score variable, go set score, connect this up like so. And then we want our score to basically be the current one plus 1. So for this, I'm going to drag in the score variable again, go get, and plug this into an add node, which we can then plug in there. And on this add node, we can simply set it to be score plus 1. So right here, this event is essentially increasing our score by 1. But what if we want to send over a custom amount? What if different things give the player different amounts of score? So we would want to change the amount of score that gets added each time this node is run. So what we can do is select the add score node. Then in the details window, you'll see at the bottom we have inputs. Now let's go ahead and create an input here. And it's going to create an input like so. You'll see it then gets added to the node, and we've seen these before, okay? The tick node, if we create tick right here, has a delta seconds input, and this can then be used by us when we run nodes connected to event tick. Likewise, we can have add score send over data this way. So I'm going to rename the input to be amount, basically the amount of score to add, and I'm going to set its type to be integer, and there we go. Now what we can do is simply drag the amount into the addition node here. So now instead of adding 1, it is adding whatever the amount here is. And you'll notice up here where we are calling or running the add score event, we now have an amount input that we can define. So if I set this to be 5, that is now going to add 5 to our score. Or if I set this to be 20, that's going to add 20 to our score. Now what I want to do is after I go ahead and set the score, I then want to print out the new value so we can see it. So we'll simply print that, convert that to a string, and there we go. So now add score, I've set to be 20. Let's save, compile that, and then if I go ahead and run, you'll see it says 110. That is of course because our score by default is 90. Let's set that back to 0 just to make it a bit simpler. So yeah, that works. And what this means is that we can easily run these nodes as many times as we wish. We could simply then go from here to another add score node, and maybe this time we want to add 220, or let's say we just want to add 9. We could then add another add score node. This time we might just want to add 55. And as you can see, we are essentially shrinking the amount of nodes we need, because otherwise, in order to add the score 3 times, we would have had to copy and paste these 3 times like this. But since we have combined it all into a single event, that means we just need to call the event node here, and it will run each time, sending over a different amount. So now if we go ahead, save, compile, and run, we should see that we have all that score being added up right there. Okay, so hopefully you can see how powerful events can be. I want you to go ahead and complete this challenge. I want you to go ahead and create a health variable, set that to whatever number you want, maybe around 100, and then I want you to create an event which is called take damage. That take damage event must also then have an input, which is the damage amount. And then I simply want you to subtract the damage amount from the player's health and then print out the final health. Okay, so have a go at that, and I'll see how you're done in the next lesson. Okay, so I hope you had a go at that challenge. Pretty much what we're going to do is create a new variable here called health. I am going to go ahead and set health to be of type integer. We can then compile and set the default value to, let's just say, 100. Okay. Now what I'm going to do is create a new custom event by right-clicking and going custom event. I'm going to call this one take damage. Take damage like so. Now this take damage event is going to have an input, which is going to be the damage amount. So let's create a new input here. Call this one damage amount. And this is going to be of type integer as well. So now what we want to do is essentially subtract damage amount from our player's health. So I'm going to drag in health, go set health, plug the execution flow like so, drag in health again, get health, and then plug this one into a subtract node, and we want to have it set up like this. Now make sure that health is on the top because this is the number we are subtracting from, and damage amount at the bottom here in B is going to be the number we are subtracting from A essentially. So we can then go ahead and plug this into the health input here. So we are setting health to be that new result. And then finally, we want to print out our health. So we'll plug it in like so. Okay. Finally, let's go ahead and run this. So up here, I'm just going to delete where we are adding the score and instead plug in the take damage event here. Now, you may notice that the damage amount is just called new param here, new parameter. This is because we just need to compile. Once you compile, you'll see it results in this error, so we simply delete that and then go take damage again, and it should be fixed up here. You can just close that compiler results there. Okay, damage amount, let's say 20. Now we can save that, compile, back in our level, let's run, and we should see 80. Okay, we started with 100, and then we subtracted 20. So, hope you had a go at that challenge, and from here, just keep experimenting with events. So thanks for watching, and I'll see you all in the next lesson. Hey everyone, in this lesson, we are going to be looking at how we can begin modifying properties of components inside of our visual scripting. So far, we've been looking at variables, events, conditions with the branch node, but we haven't actually done anything gameplay related. This has all just been printing stuff out to the screen. So now let's actually get affecting the game itself. So to do this, inside of our blueprint here, what we can do is, first of all, look down on the left-hand side here, okay, where we have variables. You'll notice we have a little drop-down called components. Now, you'll see we have two components. We have cube and default scene root. And you may be wondering, why are these in our variables list? Well, whenever a component is added to our blueprint here, it automatically becomes a variable we can set and get, just like with the ones we created down here. What that means is we can modify these variables, which are a reference to their corresponding component. So let's, for example, drag in our cube. We can do this in two ways. We can go down to the component list here and drag in the cube and simply go get cube, or we can actually select the component itself in the components list and drag that in to get a reference to the cube component. Now, what can we modify on our cube? Well, if we select the cube here, you'll see in the details panel, we have all of these things here. And most of these properties you see on screen can actually be modified and gotten inside of the blueprint editor here. So for example, if we wanted to change whether or not gravity is enabled, if we wanted to change the damping, we could do that here in our blueprint. But something I think that would be a bit more visual is if we, for example, changed our material color, okay? So what I'm gonna do is I am going to go from my cube node right here and plug this into a set color parameter value on materials node. Now this node right here basically looks at whatever target we have assigned, which is our cube, and it gets its material. And on that material, it searches for a parameter name. In this case, we want to change the color parameter, and then we can give it a value. I'm going to click on the little black square, and let's say we want to turn our cube green, okay? We can then connect that to our begin play node, and if we save and then compile, let's go back to our test level, make sure you have your cube in the level here and press play, you'll see that the cube has turned green. And again, that is because what we are doing here is modifying our cube component. We are accessing its color parameter on its material and changing that to be green. We can change it to also then be blue, for example, like this, save, compile, press play, and there we go. So that is how we can affect a component and modify its properties. Now, each component is going to have different things that can be modified and different things that can't. For example, with a light, we're not going to be able to change the light's texture. Just like with a cube, we're not going to be able to change its brightness, okay, relatively speaking. So let's look at creating another component such as a light and then modifying that. Well, I'm just going to go add here for the component, and I'm going to search for a point light, okay, just like that. Now what we can do is drag, or let's actually go back to our viewport here and line up our point light. So I'm going to select the point light, and we can then modify its location. Let's just have it above the cube here. Let's also change the intensity so it's going to be a bit brighter. And by default, let's make the color, we'll make it a reddish orange, something like that. So if we save and compile and go back to our test level, that's what it's going to look like. Well, Inside of our event graph now, what we can do is drag in that point light component, and then we could modify its properties. So let's select the point light and have a look at what we want to change. Let's say we want to change its attenuation radius, okay? Let's say we want to make the attenuation radius bigger. How would we do that? So we can drag out from point light and simply search set attenuation radius, and we want to go down here, okay, and select this one. Now, as you can see, we can define the target, which is going to be our point light, and then a new radius, which let's just say we're going to bring it down to 10, okay? We're going to make it very small. Now, we also want to change our material of our cube, so I'm just going to drag these two nodes over here and just connect it up like this by making it look a bit more compact, okay? And connect that like so. So our little program here is going to change the cube's color to blue. Then it is going to set the attenuation radius of our light to be 10. So save, compile, and then if we press play, you should see that the attenuation radius has shrunk pretty much down to nothing. So in fact, let's maybe bump this up to be 50 centimeters, compile, play, and there we go. It's still not too visible because the light is being shrunk down very small. Now, what if we wanted to affect the blueprint actor itself? Okay, right now we are modifying its components like the light or the cube 3D model. But what if we want to actually modify the position of the test cube itself? Well, we don't want to move the cube model as that is going to keep the actor still while moving the component around. We want to move the actual actor itself. So to do this, what we're going to do is inside of our blueprint, I'm just going to delete this right here so we have a nice blank slate. We could right click and, for example, go add actor, and you'll see here we have add actor local offset. This is going to add a position location offset, so we can connect this up. Delta location is going to be the offset, so let's say we want to move 100 along the x-axis there. And there we go, that is all we need to do. Now you may be wondering, well, we haven't set a target. How does it know if we want to move the actor, the point light, or the cube? Well, you'll see here, in this little box here, it says self. And whenever it references self, that essentially means the actor itself, okay, and not one of its components. So if we save and compile this, go ahead and press play, you'll see our cube has moved. It's a bit hard to see, so let's go back to the node here and just set this to be maybe 0 on the X, and perhaps we'll go 200 on the Z. Now, if we press play, we'll see that the cube has moved 200 centimeters up into the air, okay? And there we go. So that is a quick look at how we can use components inside of our blueprint to start actually affecting our game itself. Congratulations on completing the course. We just finished looking at learning the Unreal Engine. We started from the very beginning, from installing the engine to creating a new project. We looked at all the different fundamentals, from the editor overview, working with actors, lighting, physics, looking at how we can create blueprints, and then we moved on to visual scripting. Okay, and visual scripting took up a large chunk of the course as we looked at variables, events, conditions. We looked at creating custom events. So hopefully by now you can see how Unreal can be a very powerful engine, and there are a wide range of features to further learn and explore, such as animation, audio. There's an entire level design with terrain and dragging and dropping models. There is a lot that the engine has to offer, and hopefully just by looking at what games have been released out there in the world, some of the biggest ones out there have been made with the Unreal Engine. So it is a proven piece of software and is definitely worthwhile learning, as it's only going to get better and better with the updates that come in the future. Zenva is an online learning academy with over 1 million students. We feature a wide range of courses for people who are just starting out or for those who just want to learn something new. The courses are also very versatile, allowing you to learn in really whatever way you want. You can choose to view the online video tutorials, read the included lesson summaries, or follow along with the instructor with the included course files. Thank you very much for following along with the course, and I wish you the best of luck with your future Unreal games.